All right, sorry I'm not here to do this in person. Hopefully, I will be back tomorrow. So, we're going to talk about standard angle position, converting from radians to degrees and vice versa, as well as reference angles today. So, you need to watch the entirety of the video, and then I'm going to type out the problems that you need to turn in. It's up to you whether you want to put the notes on the same page as what you turn in. You will eventually get back what you turn in, so you can decide, but you will need to turn something in. So just make sure that you keep that in mind as you are going through. So we're obviously still dealing with trigonometry, and the first thing we're going to talk about, and I'm going to type some of these and then I'll handwrite some things too, but it's easier to use this if I can type. So first thing we're going to look at is standard position of an angle. And when we have standard position of an angle, there are several things that have to be true. First of all, we need the initial side to be the positive x-axis. So initial side is the positive x-axis. Always. Every time we're asked to draw an angle in standard position, that's always going to be true. And angles in standard position are how we use angles on the unit circle. So again, we're leading up to creating and making sure you know how to use the unit circle. So we're going to start on unit circle things in the next lesson. So this is all kind of the building blocks that you need to understand it, along with the SOHCAHTOA that we did the other day. When we are talking about the standard angles, we can have both positive and negative angles, and the difference in those is the direction that they rotate. So positive angles are going to rotate counterclockwise, so start at the positive x-axis and move through quadrant 1, 2, 3, and 4 in that order, whereas negative angles are going to rotate clockwise. So meaning a negative angle is still going to start on the positive x-axis, but it's going to go through quadrant 4 first. So just as an example, if I am drawing my two axes, the angles, I'm going to change color here, maybe, if it lets me. There we go. So a positive angle, let's say we wanted to graph positive 200 degrees. And of course it's not letting me. I mean, you can see on here that I have selected this lovely red color. Let's see if it likes blue any better, but it doesn't look like it wants to let me change colors. Nope, it does not. Okay, so we're just going to go with that, I guess, since it does not want to let me do that. So we start, and you always have to show the rotation. So I start on the positive x-axis. 200 degrees would be 20 degrees more than 180, so about right here. So I've rotated counterclockwise, starting in quadrant 1. When you graph an angle, you have to draw the arc, just like I have here. You draw the terminal side, which is always a ray, that shows where you end, and then you also have to label. So I label right on my rotation. So this would be how, if you were asked to graph 200 degrees in standard position, this is exactly how it would need to look. You would need to have the axes, the rotation, the label, and then the terminal side. So let's say I wanted to do negative 60 degrees. Negative 60 degrees is going to rotate in the opposite direction. And so it would look like this. Again, notice that I've got all the same pieces. I've got a terminal side, I've got the rotation, and I've got the label. So those are your examples for standard position angles. Now, we need to talk about what radian measure is, because we're going to be talking about whether we use radians or degrees, converting back and forth between the two. So radian measure, when we're talking definition-wise, is the length of the arc that's associated with the angle. So if I want to draw a picture for that, let's say I am looking at a familiar angle of 45 degrees. So I'm going to use a familiar one because everyone knows where that should look. So if I have a 45-degree angle, which graphing it in standard position would look like this, radian measure is the arc that's associated with the angle. So let's say that instead of just drawing this arc, I draw an entire circle. And excuse it for not being as circular as it could be. It's hard to draw with this thing. The radian measure is actually this guy right here that I just squiggled, because that's the part of the circle, it's the arc length that is associated with the 45-degree piece of the circle, if you will. So when we're talking about radians, I'm going to ask you to have memorized some radian measures. And really a lot of these are intuitive, because if I were to divide this circle into equal pieces, right now I've got 2 pieces in this quadrant. So quad means 4, right? So if I were to divide each quadrant into 2 pieces, that means that my entire circle would have a total of 8 pieces. So 45 degrees is the entire circle's length, which we call that circumference, right? Which is 2 pi if we're using a radius of 1, which is what we do in the unit circle. So the length around the entire circle is 2 pi. 45 degrees is 1/8 of that circle. So 2 pi divided into 8 equal pieces and then reduced is pi over 4. So 45 degrees in radians is pi over 4, because radian equivalent is always given for a unit circle where the radius is 1. So here are some radian equivalents that you really just should know. You're not going to need to know all radian equivalents, but there are a few that you really, really would benefit from knowing. So 30, 45, 60, 90, 180, 270, and 360 degrees are the ones that are pretty standard, that it would be really helpful for you to know. 30 degrees is pi over 6. 45 we just did, it's pi over 4. 60 degrees is pi over 3. 90 degrees is pi over 2. 180 degrees is pi. 270 is 3 pi over 2. And 360 degrees is 2 pi. So these are just some important equivalents that you really, really ought to know. So we've covered some radian equivalents, we've covered what radians mean, we've covered how to do standard position. The next thing we're going to talk about is how to convert from degrees to radians and vice versa. So to convert from degrees to radians, we will always take whatever the measure of the angle is, so let's say x degrees, and multiply by pi over 180. and that will give us our radian equivalent. When we instead want to convert from radians to degrees, it's pretty simple because all we're going to do is take x radians and multiply by 180 degrees over pi. So it's just the reciprocal, and the way you can tell the difference is if you want degrees at the end, like this one, then your pi's should cancel out. If you want radians, you should have pi in your answer, so that can help you make sure you don't do the wrong one. So we're just going to do an example of each here. So say we have 164 degrees. So this is one that's never going to be on our memorized list. It's not a unit circle value. It's not a common value. So we're not going to need to memorize that. So I would take x degrees, so 164 degrees, and I would multiply by pi over 180 degrees. Now remember, when we multiply fractions, we generally do top times top and bottom times bottom. This one doesn't have a denominator, so we assume that that denominator is 1, and so that's going to give me 164 pi over 180. And then I need to reduce that. So we need to figure out what common factor all of that is divisible by. We know, obviously, since they're both even numbers, that they're both divisible by at least 2. I'm going to look to see if they're both divisible by 4. 160 divided by 4 is 41. So I would say that's going to be our winner. Divide top and bottom by 4. So that gives me 41 pi. 180 divided by 4 gives me 45. So in radians, this is 41 pi over 45. All right, second example of this type then, we're going to start out with 5 pi over 12, which is a radian measure. So 5, why did I write 15? I don't know. 5 pi over 12 times 180 degrees over pi. So here, and I could have done the same thing here, but I didn't really know the common factors off the top of my head. Remember that you can cross-reduce things if that's easier for you. The reason I say that here is because if I do 5 times 180, I'm making the number bigger, where here I can see that the pi's are going to cancel each other out, and it's probably easier to find common factors between 12 and 180 than 12 and 5 times 180. So if I look at 180, it itself is divisible by 12, so 12 divided by 12 is 1. 180 divided by 12 is 15. So that makes everything cancel in my denominators, and so I just have 5 times 15 in the numerator, which gives me 75 degrees. All right, hopefully that seems pretty easy. And now we're going to go on to our last definition here, last thing that we need to take care of. Now, for some reason, this thing does not want to show me the scroll bar until I move things well. So, okay, sorry about that. So last one that we're going to talk about are reference angles. And a reference angle, by definition, is the angle that is formed by the terminal side of a given angle and the x-axis. One thing that's really important is that reference angles should always be acute. So, of course, you know from geometry that that means that the reference angle, we use alpha as the symbol. It's a Greek letter. So that means between 0 and 90 in degrees. If you look up at the chart we wrote earlier, why did I write the degree sign again? That means in radians, it's between 0 and pi over 2. So make sure that you're not listing an angle that's bigger than that. So I'm going to show you a couple examples of how to find a reference angle here. So we're going to look at 240 degrees first. And here it would be super helpful if my colors were working, but they're not. So I'm just going to draw two separate coordinate planes to illustrate for you. Or maybe I can get, I don't know if I can get a highlighter to work maybe, but probably not. So we'll just do this. So first thing I always do when I'm asked to find a reference angle is draw the original angle. So 240 degrees. So if I rotate from standard position, this is 180. So I'd need to go 60 more degrees to get to 240. So it should land about here. This is 240 degrees. If I am drawing the angle by the definition, it's the angle formed by the terminal side. So that would be, sorry, I'm having a lot of issues today. This is the terminal side, and then it's the x-axis in that quadrant. So I guess I don't need a different color. I was able to highlight it big enough. So this right here that I have just drawn darker, that is my alpha. So however many degrees that is my answer. So in this case, alpha represents how far past 180 I went. So I went 60 degrees past 180, so my reference angle is 60 degrees. 60 degrees is definitely acute, so I know that falls into my definition. All right, I'm going to do one more of these, and I'm going to start out with 25 pi over 12. So I wanted to do this one as kind of a warm-up for what we'll do with the unit circle tomorrow. But 25 pi over 12, this is obviously an improper fraction. I find it easier, and if you don't, that's fine. You don't have to do it this way, but sometimes I write these as mixed fractions to help myself. So 12 goes into 25 twice with one left over. So that's 2 and 1/12 pi. These are the same. 2 and 1/12 pi, same as 2 pi over 12. So if I look up at the chart of radian measures that I said to know, 2 pi is 360 degrees. So when I'm graphing this in standard position, yes, you can have an angle that goes around more than once. So you can have angles that are infinitely big. You just keep making circles. So 2 pi would be here. So I'm going a little past that to land about right there. So this is my angle. This is my 25 pi over 12. My reference angle, again, by definition, and I would, if I were you, highlight or use a different colored pen. This is the terminal side. This is the x-axis. So right here is my alpha. So in this case, alpha represents how far past 2 pi I went. So in this case, I went 1/12 past pi, so pi over 12 is going to be my alpha in this case. Always, when you are asked for a reference angle, you need to write the answer in the format of the given angle. So this was given in radians, the answer should be in radians. This was given in degrees, the answer should be in degrees. So hopefully that makes sense. Now I'm just going to write out the ones that I want you to try and turn in. So up to you whether you want to turn in the whole paper or write these separately. Make sure you put your name on it too. So number 1, you are going to draw the angle in standard position. And the first angle you're going to do is negative 160 degrees. Then you're going to do 510 degrees. And then you're going to do 9 pi over 8. So those are your first three. You'll need to leave yourself space, of course. Then, second thing, you are going to convert to the opposite radian degree format. And you are going to convert 220 degrees and then negative 5 pi over 6. Last one. Find the reference angle. (310 degrees), negative 100 degrees, and 4 pi over 5. So on number 1 and number 3, you're going to need to draw pictures. Number 2, you're going to need to show work. But that's it. Shouldn't take too long. So once you finish those, turn those in, and I will check them when I get back. Hope you have a good day.